In this lab, you are learning about voltage, current, and resistances in a simple circuit. And we will verify Ohm's law. This is the objective of this lab. Okay. To start this lab, let's go to this link. It's already here. Let me cancel it and connect. Click on this conventional to set up the lab, and you have to click here on labels to see all the instruments what they are, right? If you click, if you don't click it, we don't know what it is. Something you know, but some other things you may not know, because these are all the symbols for electric circuits. To get here, there are a few more, right? So click on labels, and then you will get all these things. And if you click right here in plus sign, then there are more options. Then here is the wire resistivity, right? Pull this block all the way right, get lots. Okay, so it means the resistivity of wire, these wires will be a lot. Okay, so if you don't need resistivity, you can put it tiny, right? Right now, for the first part of the lab, I need a lot of resistivity, because in the first part, I'm constructing Ohm meter that measures the resistance, right? That's why I'm putting lots. Okay, let's go to the manual. So selecting conventional and all these things are done. And now my Ohm meter should look like this. Okay, so to construct Ohm meter, what I need is current. No, this is ammeter, voltmeter, and a battery. That's all I need. Let me make it. This is voltmeter. This is ammeter, right? So I can put it here and here, right? So my Ohm meter is ready. Right now, I can measure it. But before doing so, just select this one, that is battery, and pull this block all the way right, which is 120. Now, my Ohm meter is ready to measure resistance. So let me bring this resistor on the workspace, and let me go to the manual. What I need to do, here is the table, right? So selected value, I can select a value, any value I would like, 10 ohm, 20 ohm, 30, 40, and so on. I can measure the current through the circuit. Potential difference by using voltmeter is there, right? And then I can calculate the resistance. So in this way, this device as a whole acts like a Ohm meter, right? And extra resistance. Will see what is that extra resistance. Okay. So if you click it here, this is the resistance that we have to choose for first value, right? First data, 10. This is the selected. Now measure the resistance. To measure the resistance, let me connect in this circuit. Current will be stored, right? So look at here. Here is the potential difference, and here is the selected value is 10. Selected value of this resistance is 10 ohm. 8.71. Let me write down here. So my data here is how much was current? 8.71, right? And what about this one? This one was 120. If I calculate resistance, which is by using Ohm's law, I can calculate it. R is equal to V by R. So 120 divided by 8.71, right? it gives me 13.77. Okay. 13.8. This, okay. So extra resistance means we select 10 ohm, but we are getting this one. 3.8 is extra, right? That's why I can write down here 3.8 ohm as an extra resistance, right? Where does this extra resistance came from? It came from these wires because I select resistance. I select the resistance of wires lots, right? So that's why, in general, if I put this wire resistivity as a tiny, then there should not be this much resistivity. It should be same like the resistivity of this resistor. But I select lots. That's why I'm getting extra, right? So this is one. Then let me clear this one. And then, yeah, next you can increase the resistance now and do the same thing. Repeat step 1 until you completed this table, right? So how to increase the resistance? To increase the resistance, just select it. Right now I need 20, right? So click increase here, right? It's 21. Look at here, right now, it is the value of current is changing, right? So if I do the calculation, voltage is 120 divided by 5.05, right? 0.5. It is coming something 23.76, right? Right now, the resistance is increased, okay? So the extra resistance that we get here in this table, after calculating the resistance, is from wires, these wires, right? These wires. Okay. So once you completed all data for this table, you can plot a graph between resistance and current in your Excel sheet and insert right here. Okay, so your plot should not be linear because this is not Ohm's law, right? This plot is resistance versus current. We are keeping voltage, that is potential difference, fixed at this time, and changing resistance and changing current. Okay. So after completing this part, in second part, we are verifying Ohm's law. So your overall job is to plot IV curve. I is current, V is voltage. Okay. So let's go to the second part. Your circuit should look like this one. This is the rheostat having constant resistance, right? Not changing. And here is the emitter, battery is here, and voltmeter. Make sure voltmeter should always be connected in across, right? Parallel. And emitter should be connected in series in the circuit. This is the general norms, okay? So let me just get back everything. And first put these resistances in series. I need, according to manual, I need 8 resistances, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 7. And right here, 8. Okay. So I need to put I need one battery here, and then connect to wires like this, right? So this one should be connected across the resistance rheostat right here, right? So right now we are keeping resistance constant, which is 81, right? We are connecting, let me see the value of individual, 10 ohm. This one, 10, 10, 10, 10, 10, 10, 10, 10. Yes, I'm checking, and this is good. All are connected in series. And when, remember, when your combination of resistances are in series, it will add off, right? Individual resistance value is 10, so equivalent is 8. Okay. Now your job is to measure voltage and current. That's all. So first set the selected voltage 20. From here, voltage of, if you click it here, you can set of this one to 20. Right? So if you set of 20, your current is 0.25. Right? So your next data, you can write it down here. You can write it down here. What was the voltage? Voltage was 20, right? We set of 20. And then what was the current? Current is 0.25, right? So you can calculate, you don't have to calculate here, but if you calculate, it will be 80, right? 20 divided by 0.25 give you 81, which is correct. It means we are doing correct. Okay. So let's go back and increase the resistance, the potential to 40. Right. If I increase to 40 from here, okay, what is happening? Just wait. Clear all. Okay. Okay. So, okay. Now I need a battery here. I'm doing something. I misplaced something from here. That's why it's making some problem. Okay. So you can set off 40. Voltage should be 40 right now. Right? So what happened to the current when I increase the potential difference? It is doubled, right? If I make 80 here, see, it's 1 watt, right? It starts from 0.25, increased linearly as I increase the potential difference. Okay, so that in this way, we can complete this table and finally draw a plot by using Excel. You can draw IV curve and so your IV curve should be linear, right? If you are not getting linear curve, make sure your plot should be perfect. There should be slope, everything should be, ligand should be there. And then what is the variable along the y-axis and the x-axis, everything should be clear. Okay, so after drawing this plot, just insert below and finally summarize what you learned from this lab. Okay, I hope you get it. If you have any question, you can ask me anything.